12/12. So so that's the second rule. Since it's a habitable location, it needs a receptacle within 6 feet of every opening and 12 feet in between these receptacles. So that's basically what the idea of this is. Uh, this will tell you guys that we're going to be talking about the requirement for receptacles, the calculation for laundry, and laundry receptacle requirement. We'll go ahead. If you decide, who decided to, we'll talk about the laundry receptacle in a few seconds. In terms of exhaust fan, guys, do we decide that the attic need an exhaust fan as electrical engineers? We don't decide that if the attic is going to be an exhaust fan. It's mostly mechanical building contractor decide to, if you have an attic fan, it makes your house easily cooled or easily heated, easily cooled or easily heated, circulate the air. But if you decided to do so, we're going to learn how to wire it. Okay, here's the circuit that we're talking about right now. We have a receptacle outlet for the dryer. We have a dryer receptacle outlet. What do you guys expect? Why do we have 3 conductors coming to the dryer? Typically, 240, 120, single phase. So long story short, here's my circuit. Will be coming right here. This most likely for the dryer would be 30 amps. Your dryer 30 amps for 240 volt / 120 volt, wired with number. How many conductors? 3 conductors number. 3 conductors number. If it's 10, 30 number 10. 3 conductors number 10 for the dryer. So that's what we typically guys do for dryers, right? Why do we have the 240? We're going to learn why do we have 240. In a dryer, there are 2 types of loads inside the dryer. Dryer is an appliance. 2 types of load inside it. We're going to see it. One of them is the heater. The heater, they burn the heater at 240, and and also, so you need to create heat, and also you need to move the stuff inside it. That movement happens with a motor that's running at 120 and a couple of lights. So the 120 for the motor and a couple of lights and control, and the 240 for the heating element. Okay, how about this circuit? Since it's a laundry by code, you need to have a dryer. If a dryer is there and the dryer electrical, you need an outlet for it. How about the other outlet here? This is by code also. You need a 20 amp dedicated circuit, 20 amp dedicated circuit feed. No other outlets for the laundry area. So this is my 20 amp dedicated circuit for the laundry area. Anybody has an issue with that code? We're going to see where the code says 20 amp dedicated circuit for the laundry area. How about the rest of them? Can I add another circuit? I can add as many circuits, but minimum you need these 2 circuits, the 20 amp and the 30 amp if your dryer is electric dryer. A lot of people guys get confused. Every dryer is an electrical dryer. Every dryer is, well, almost every dryer is an electrical dryer, except when we say an electrical dryer, we mean the heating element is electric, not gas. A gas dryer is also electric dryer, right? You have a motor to circulate, that's electric, but when we say electric dryer, we mean the heating element is electric. Any question guys about this circuit? Straightforward, right? Any question? So that's our laundry area. Since appliances, guys, a couple of things. Since the dryer and the washing machine are appliances, and the range, appliances by code, if you go to article 220.33a, it will tell you every appliance need a disconnect. So your choice. Either you have a nice big fat disconnect like this, or it allows you to use the plug as a disconnect. And most of the time, what do? We plug him in, so we have a disconnect as a plug. So keep in mind, guys, they need a disconnect. Very important. When you have appliances, what are appliances? Appliances commercially available in a standardized sizes, equipments, mostly for residential, right? A good example would be a dryer, range, washing machine, and so forth. So keep in mind the disconnect. Please keep in mind the disconnect for them. Dryer and range disconnects are sometimes come as identical. The most common, we talked about this one, the most common for the dryer is what? 30 amps for the dryer. And how many wires? How many wires? 4 wire, including the what? The ground. Yes, sir.
I don't think any of my appliances have ever had a disconnect.
Are they plugged in?
No, they're hardwired.
Hardwired?
Yeah.
Huh.
Like they have just a,
Is there a switch right next to them?
no, like four screws on the back and they just wire it and screw it in.
Hmm. We have to have either plug-in or a disconnect. Are they within sight of a circuit breaker?
No.
Because your circuit breaker work as a disconnect. So no circuit breaker within sight, no disconnect or no plug. All right, go with one. To meet the code. So dryers, as we say, guys, dryers run at 12240. So as you send, how many conductors you're going to send to it then? 2 hots, neutral, and ground. Are they 3-phase or single-phase the dryers in residential? Single-phase, 2 hots. Connections. Here talks about connection, guys. I have a couple of, either you EMT it. Most of the time, what do? We have, for dryers residential, we use Romex all the way coming, and we plug with a plug, right? Box and plug. But you can EMT it, you can have flex it, you can have a flex, you can flex it, so you can EMT it, you can have a couple of other outfits. I'll show you a couple of pictures, guys, that talks about this. Here's an example of manufacturer outlet cable. So in this area, here's your option. The option is to put big fat disconnect right here and tie these directly. And then here's my disconnect coming in and coming right into here. That's one option. The other option is to grab these 2 wires, put them in a plug, and then this will be your disconnect. The plug will be disconnect. Another option, guys, if this is within sight of a circuit breaker, 30 amp circuit breaker, if it's within sight of a 30 amp circuit breaker, then the circuit breaker will act as your disconnect. But you have to have a disconnect. You have to have a disconnect. Everybody knows what a disconnect is. Disconnect is safely disconnect the equipment so Mr. Erbab can work and maintain it. Overcurrent protection device, everybody knows what overcurrent protection device. Short circuit, ground fault. Yes, sir.
Why would you not, like, what would be an instance that you wouldn't put a plug on the internet? Why would you put a disconnect, or why would you run it to a circuit breaker? Why?
The easiest way is a plug-in. Plug, if it's rated, plug it in.
So, I mean, and it's most cost effective.
Yes, in appliances.
Yeah. So
In
I mean, I'm
appliances.
just wondering
Where would
especially
be,
residential, because this is residential. Right?
yeah, where would be an application
Yeah.
where you don't plug it? I'm going to give you an example of an appliance that you cannot plug. Water heater. Water heater is an appliance,
Yeah.
not this. You can't plug. So what are you going to do with it? You need it's an appliance, you need a disconnect for it. It's an appliances, and you need a disconnect for it. So what are you going to do? Either you put it right within sight of a circuit breaker, so you can turn it on and off. That will be your disconnect. Or the next option is to have one big fat disconnects on the wall. So that's an example that comes to my mind. Not a dryer, not washing machine, and a
You can't,
water heater.
you're not within viewing distance of your.
If you're not within
you need to
sight,
disconnect them?
yeah, you need a disconnect for water heaters. It's an appliance. Any other application good for? I can't think of any dryer and washing machine application honestly in residential that you need a full spiel disconnect. Full spiel disconnect. Anybody can think of an application? The cheapest, easiest way will be to plug it in. Here's another application. But here's the key point, guys. No matter what you do, you need this flexibility. Everybody knows why we have this flexibility. Move the equipment. You can't rigid this equipment or EMT it. You know, for 2 reasons. Number 1, you can't move it then. Or number 2, vibration. As this dryer moves, the whole house will be moving with it. So vibration. But there's a lot of connection, guys, converters, since you're not an electrician, but as a project manager, there's a lot of fittings that can convert you from PVC into EMT, into, in this case, from EMT into flexible conduits. If I can't think of a place where the equipment, other than physical damage, if your equipment needs physical damage, guys, so you need an EMT for physical damage, not extreme physical damage, and you can't use a cable, so you need to EMT it to the equipment, and somehow you still need what? Somehow a plug or a disconnect. In this case, would be a disconnect. EMT to the disconnect. Does that make sense? EMT directly to the disconnect. Here's the most common way, like you said, Mr. Boo, my friend. You got your 30 amp for wire 120. Looks beautiful, right? Cord. Why do we have a cord? Flexibility. Why do we have a plug? Disconnect. Everything is sized beautifully. You have your cable coming in or your conduit, whatever you, most likely your Romex cable coming in. A couple of things about the dryer. I have a nice picture, guys. The dryer has two parts. The heating element burning power at 240 and the motor is running at 120. So that's why the heating element is running at 240 and the motor and a couple of lamps, a couple of motors and lamps versus the heating element or elements. Does that make sense? Two parts is a dryer, heating element and a motor for the most part. Heating element burning at 240, motors burn at 120. When we do load calculation, which we will be doing this week, the code, by code, you have to allocate 5,000 volt amp for every dryer or the nameplate, whichever is larger. So as we start doing load calculation, which we will be doing this week from A to Z, you're going to allocate a 5,000 volt amp or watt all the way to every dryer or the nameplate, whichever is larger. So let's pick on my friend Muhammad, my friend. If the nameplate says 5,500, which one would you use? The 5,000 or the 5,500? The largest. The 5,500. These are easy questions because I answered them, right? Now let's pick with DJ, my friend. If your dryer says 4,500, you're going to choose the 5,000, no matter what. Okay. And again, the load is divided evenly between the 240 for the most part. For the 240. What we do, guys, when we do the load calculation for these, we take the volt amp divided. We take the volt amp divided by the 240 volt, and then whatever amp we come up with in residential, we go to the next standard conductor and the next standard overcurrent protection device. We don't multiply it by 1.25 for the most part in residential. 240, the volt amp. So if I have 5,000, you take my 5,000 divided by 240 to give me the amps. What's my amp? Anybody has a fine calculator? I already put the 5,000 divided by 240 equal 21 amps. That will give you 21 amps. 21 amps. 21 amps. We'll talk about appliances, guys. The appliances, for appliances, let's do this calculation. So let's see, for appliances, since it's appliances, 21 amps, when we do the calculation, you go 1.35 and you size the overcurrent protection device based on 1.35. And so you take the 21 multiplied by 1.35. Anybody can give me the answer here? Appliances, I'm going to go tell you where you got this information. 28. 28 amps. 28 amps. And you go to the next standard overcurrent protection device. What would that be? 30 amps. 30 amps. And if you don't believe Chad, because you are doubting Thomas, huh? This will be 422. Let's go to 422, will you? 422. And of course I lied to you. 422. Okay, it's actually, let's do this example. Let's do this example again. It's the 35 is a different one. If you guys go to article 422, let's write the article here. The article is 422.422.11E. Are you guys there? 422.11e. 422.11e. If you go to 422.11e, you see a single non-motor operated appliances, single non-motor operated appliances. That actually applies for single non-motor operated appliances. If the brand circuit supplies a single non-motor operated appliances, is the dryer a non-motor operated appliances? So that does not apply to it anyway. That does not apply to anybody. Can give me a single non-appliance range. What else? Range or water heater. Range or water heater. So for the most part, guys, for these most of the time, we can come up with the next standard overcurrent protection device. Next standard overcurrent protection device will be 25, and your conductor size, you can't put on 25. Can you put on 25? These are appliances, not motor alone. You have to go to number 10. And for the most part, you end up with having the number 10 conductor with the 30 amp as a standard carry. The way as a standard carry, 30 amp conduct, 30 amp overcurrent protection device with number 10 conductor. We're gonna get to the appliances, guys, non-motor appliances as we go through. I want to make a calculation here. We talked about the laundry receptacle. You have to have 20 amp and shall not feed any other things. Very important. 20 amp dedicated for the laundry. That's for the laundry, the washing machine, and shall not feed other receptacles. If I have a receptacle in the back, can I feed a receptacle from the back from this 20 amp circuit? No. 20 amp circuit dedicated for the laundry area. Dedicated for the laundry area, 20 amp. Now, you guys remember we said if you have a receptacle within 6 feet of a sink in a laundry area and basement, where else was laundry area, basement, wet bar. If you have a receptacle within 6 feet of a laundry area, basement, or a wet bar, this receptacle have to be GFCI. So keep this in mind. Here's where the 6 and the GFCI rule. So long story short, this receptacle will be what? GFCI. This receptacle will be most likely a GFCI receptacle. Any question, guys, about this 20 amp dedicated circuit for the washing machine, for the laundry area washing machine? No other receptacles. Has to be GFCI if it's within 6 feet of the sink. So that's all what we have about the laundry area. Moving to the attic, there's a couple of wiring methods I want to show you guys for physical protection of attic. If your attic is accessible, you have to protect the wiring from physical damage by guarding stripe. I have a couple of pictures I'm going to show you. We'll talk about these. Here's a couple of pictures. If you, only if your attic is accessible, then either you drill the wires, and these are only for project managers, you know. So if it's accessible attic, what is an accessible attic? You have to be able to, just having a hole does not provide it as an accessible attic. You have to have a ladder or something that you can get in and store things in the attic. Store things in the attic. If you have an accessible attic, then you have to protect them. If you put them on the top of the, what do you call these? Rafters? Joists. On the top of the joist, then what do you need to do? You need to protect them from physical damage with these wood stripes. Anybody knows why? Because if you mount things at the top of them, hopefully if you put something like this, the weight will be right at the top of these stripes, not on the cables, just for safety. Otherwise, if you don't want to do that, what do? You drill through the joist. You drill through the joist. And again, this is for probably for project managers. Pilot light. It says, do you need a light in the attic? No, you don't need a light in the attic unless the attic is accessible. If the attic is accessible, meaning you have a ladder, it's finished, you can store things, there's a floor there, and you store things, then you need a light. If you need a light, you need a way of connecting the light, disconnecting the light. So that's where this is a toggle switch with a pilot light is a very good example. So here's my light over here. I have a switch. And here's my circuit coming and feeding this area. And with this switch, there's a light here. Really, you don't have to have a pilot light switch, guys. A pilot light switch, as you turn the light on, the light, the little light over here will go on to tell you that, hey, the attic light that you can see is on. So just for safety.
Wouldn't it go off?
Well, they're
Don't they
two.
work the pilot light so that you can see it because it's dark up there? Wouldn't the pilot light be on until you turn the light on? Because you want that light so that you can locate the switch when you go up there.
There are two types.
Okay.
There are two types. Pilot can be connected to show, let me show you. One, this one, you're right, there are two types. This one, the way you connect them, this is your neon pilot light. This one will be on when the lamp is off. So this will be on when this is off. And it will be off, well, this will be on, this will be off. Does that make sense? This is an indicating, this is not an indicating light. This is, well, you can think of it as a pilot light where you can see the switch, if you want to see the switch. If you walk in the attic and it's dark and you want to see where the switch is, right? It'd be really nice to have the switch lit, a lit switch. So that's what our pilot light. Anybody can tell me how this can be on and this can be off while the current is going through both of them? Have you ever what? Lower voltage. Have it ever crossed your mind, guys, if I have, say, 2 amps going here, not 20, if I have 2 amps here, how come that this light is on and this light is off while the 2 amps are going? Thank you. The impedance, with the way they do it, guys, they designed this pilot light with a huge impedance. And as we know from Ryman's days, if you put 2 loads in series, the load with the highest impedance or resistance will hog the voltage. So they designed this one 10 times more resistive than this light. So what does that mean? It means if you start with 120 volt, most likely across this, if you go measure, you're going to have 115 volts right here. So what's the leftover across this boy? 5 volt. Do you think 5 volt has enough oomph to push the current and burn it inside this lamp? No. So this lamp will appear off. The current is going through it, but it's off. You guys have seen a lot of lights. Sometimes when you dim the voltage to a point, the light will be off, but the current is still going through it. It's not enough voltage. In order to burn power, you need a certain amount of voltage and certain amount of current. If you reduce the current or you reduce the voltage, the equipment will not give you what's supposed to give you. Does that make sense? So this will be high R, high resistance. So that's your pilot light where you need to know where the switch is located. The other one, now this is another pilot light. Look at this. This is another pilot light. So two types. This is a pilot light. So the first one, guys, you use if you want your switch. The first one, what I would use, here's my attic here. Attic. This is my room, different room, and I have my switch in one room and the attic light. The attic is in the attic, right? The light is in the attic, and the switch in a different room. That's what the scenario that you use. No, actually, this is the opposite of exactly what I wanted to do. This would be all in the attic. So you walk in, a good application of that. How come that? That's my switch. That's my switch. Okay, so all of these are inside the attic. Everything is inside the attic. Does that make sense? Why you walk in, you're looking for the switch, it's dark, you can see the light, and that's my switch. Now here's the light, the attic will be here. This is my attic. And this will be a different room, right in here. Room. So there is light in this room, walk in, and there's a switch dedicated for the attic. But I don't know if the switch is on or off. Just by looking at the switch right there, if the light is on, I know the light. If the switch light is on, I know that the attic light is on. So it's indicating light. Does that make sense? This is if it was a single phase, a single pole. This is three pole. You can have a three-way switch with a pilot light. One of them will be with a pilot light. Interesting how they do the pilot light with a three-way switch, guys. So a three-way switch would be with a pilot light would be great. Then what you would have these two in the attic or the basement, and this one in a different room, right? So you see, I'm by looking at this switch, I know that somebody have left the light in the attic on. Three-way switches. One switch here. The attic is at the top and has a light in it. I need it here if it has a light, so I can tell if the light is on or off. Anyway, so these are different designs of lights, guys. Before I let you off the hook here, oh no. Okay, a couple of nice picture. I thought, guys, you have them to share with you. Here's a typical dryer, and I want to emphasize the word. If you guys look at this section here, if you look at this section, this is my 240 section, and if you look at this section here, this is my 120 volt section. Just to give you, the heating element is running at 240. There's a couple of safety switches and control, of course. These are appliances, guys. There's a couple of safety switches and control and so forth. But for the most part, here's where you bring your circuit in, and the rest is wired inside the light. Wired inside the light and inside the equipment. A couple of other things. So we got that one, got that one, got that one plug in, a couple of plugs, plugs, three-way switches. This is the non-grounding versus grounding. I want to talk a little bit about this one, guys. Okay, for dryers and ranges, electrical dryers and ranges, electrical dryers is interesting. Electrical range for range and dryer. For range and dryer, guys, for existing, when you wire range or dryer, you have to bring an equipment grounding conductor. This is an equipment grounding conductor. You have a new installation, you have to bring an equipment grounding conductor. Old installation Brooks, my friend, they used to allow you to use the neutral as an equipment grounding conductor, only for replacing old equipment. So if you say I have a plug here, and that plug here does not have a grounding slot for it, and I want to change the appliances, no problem. You can change the appliances and still use that same circuit, and you use the equipment grounding conductor as the neutral, the grounded conductor as an equipment grounding conductor. Only existing installation. That's an exception in the code. In this case, this is new installation, new. And when the way they enforce it, at least help me guys if I'm wrong here. The way they enforce it, if you change the circuit, they force you to bring a 4-conductor cable. If you have a 3-conductor cable, means 2 hots and a neutral, and you're not changing the whole cable, you're just changing the plug, then you can use the neutral as a ground. And there's nothing wrong with that, guys. It works. Here's what we're talking about. If you go to this, now this is a 3-conductor cable coming. How am I going to ground the frame of the range or the dryer? See that this called the blue, the white conductor. This is my grounded conductor, and it's also used as an equipment grounding conductor. It's okay, exception, existing building, existing installation, that's okay. Please pay attention to this one for range and dryer. You can use, that's a very, very anti what the code is all about, guys. You cannot, can I use a neutral conductor as a grounding conductor? No, you're not supposed to. If I use it, would the system work? Yes. Would it work efficiently? Yes. Would it work efficiently? Would it work efficiently and safe? No. Safe, we drop the safe. Yes, sir.
You have to re-identify it?
Re-identify it? No. It's a grounded conductor and a grounding conductor at the same time. It's white. It continues to be white. But what does that, you know what does that mean, guys? Here's my heating element, and here's my pump. Here's my heating element coming here. It's right here. and the neutral coming from here, coming to the neutral. And now and now I tap, where's the neutral? Here's the neutral. You tap the neutral and you attach the neutral to the frame of the fridge, to the frame of the dryer or the range. Existing installation only.
Do you, peel the insulation back and then that screw, or not? Doesn't matter.
Well, here I'm just showing it. You're gonna pick
No,
the
just
easy.
curious.
Yeah,
Under the grounding screw, you got peeled back.
well, I would go from the easiest way of installation. In a case like this, we'll probably will tab it from right in here, the neutral, and tab and ground the equipment. Huh?
No, you can't ground the frames anymore.
No, yeah, this is existing.
Okay.
Existing. No, not new. This is not true for new. Existing only. And I hate to talk about it because it's not good. Talk about this one. We talked about, guys, the receptacle circuit here. Here's how they did a couple of lighting circuit, just FYI. They brought the circuit for the light, and they have a fan, I believe here. There's a switch for the fan, a switch for the light, and a switch here for a bunch of lights over here in the attic. Look at how many lights. And DJ wants to put one light in the garage. They put 4 lights in an attic, DJ. And then they grabbed, are you guys following the circuit, how the circuit is divided here? And then they stole from the circuit to feed this lamp. And there's another circuit, and then they continued with all these like 3-way switches here. I believe they're going to be turning these on and off. And what is going to be turning this? Yeah, and this one will be turned from this switch. Couple of straightforward, guys, couple of switches, turn a couple of lights. And I'm not going to wire it this time. Is what we talked about. Talk about this one. Here's the attic, guys, protecting the attic. If your attic, those are for project managers only. If your attic is accessible, you have to protect the wiring everywhere in the attic. If it's accessible, you have a ladder, finished attic where you can store things. If your attic is inaccessible, meaning just a hole and insulation, you can't, well, you're not supposed to put your bicycle right above the insulation there. A lot of people do it. So if your attic is inaccessible, this will be probably journeyman exam. If it's inaccessible, they want you to protect them up to, guys, 6 feet from the opening. Here's how you get into the attic to work on your attic, right? To work on the insulation, check the attic. 6 feet around the hole. Here's the hole for the attic. You go 6 feet in every direction. 6 feet, 6 feet, 6 feet, and you draw a circle from this area. This area, any conductor here within this 6 feet, you have to protect it. If it's inaccessible. If it's accessible everywhere, you have to protect the conductors everywhere. Are you guys following me? 6 feet, if it's inaccessible. A conductor like this here, no protection. You don't need any protection. You put them here. They are not within the 6 feet. The attic is inaccessible, as in doesn't have a ladder, doesn't have things to store in. No problem. But that's a good shot. Talked about that. And here's the wiring. I want you guys to wire this when we have a chance. Really straightforward, not hard. No receptacles, a couple of 3 switches. That's all about this chapter. Any question? Any question for Chad, my friends? Straightforward, huh? No gimmicks. Any question, guys, before we go to... Hey, my friend, look at you, man, sharp. Good timing. Should we have, guys, 4 minutes? Help my friend here, and I'll continue with chapter 16. Okay.
Hey, Josh.
Yep.
Don't sing.
Johnson had a preliminary of land on 16 trails.
Right?
There you go.
other question. Only for hope. Yes, it's not a free matter. How can you pull that big? The garage.
You guys make the coffee, huh? That's good. Feeling good, huh? Hey, Dick? Oh, boy. How's Grandma DJ doing? You Grandma still living? You know? Wow. That's too bad.
I would have been a favorite.
That's questionable. I bought my tabs and my new
Oh,
really nice.
you put them all on?
All of them,
Yeah, I did that with mine too. I think I'm just gonna do like 12 of them with motors.
Really nice. It makes it really looks nice and You can use it now. I'm used to the tabs so much that,
I didn't wanna get them, I didn't wanna get dependent on.
yeah, if you want to sit for a test, not a good idea. Not a good idea. You get used to them and then,
Cause they'll give you a phone book. Yeah, I know where you're at. I had them in trade school, and all the kids just sitting there from down there.
I'm gonna go steal some coffee just because Chad is this fiber. You got your fiber out there and get Thanks. Okay, let's go talk about the garage and see how they did their garage, guys. So if we go ahead and couple of things about the garage that we're going to talk about, the requirement, the outlets. This article, guys, the most important thing in this chapter really is garage landscaping and outdoor lights and berry. So I want you to know three things. Number one, what do we do with the garage? This is repetitive. We're going to keep repeating ourselves over and over and over. Garage light and power. Let's review, guys, the garage. If your garage is detached and you decided to wire it, then you have to have at least one GFCI receptacle. That's all. If you have a service door for your garage, then you need to have a light. And of course, you need to have a light too. Inside the garage, you need a light. If you have a service door for the garage, then you need a light outside. You really don't need a light for the garage itself, the door for the car. Light inside and one GFCI. How many circuits do I need for a garage? Does the code say how many circuits? Does the code force me to bring a circuit for the garage or circuits? Can I feed the light and the GFCI receptacle in the garage and the outside light from any, well, from say a living room circuit? No problem. A basement circuit? No problem. Is it a good idea to provide a dedicated circuit for the garage? I think so. Code-wise, do you need to do that? No, you don't need to do that. Okay, so that's what we're going to be talking about, guys. Landscaping, lights, and so forth. The most important things, landscaping lights comes pre-assembly protected. The only thing we need to do is just bury them. We'll talk about this one. Conduit, underground cables. Another thing I want to talk, guys, about how the depth, as you move between structures in a campus, on the premises, how do you move conductors underground? How deep you can bury your conductors underground? Let's go ahead and look at let's go look at how they wired this garage, and I need DJ to let me know if he agrees with this. Look what they did, guys. They brought a number 14 circuit, circuit number 14. Here's your GFCI receptacle. They brought the GFCI receptacle. So did we meet the code? Yep, we met the code here. And there is a service door. So what do I need for the service door? I need the light. And because it's a light, what do you need for the light? A switch. So this is code. Anything blue is going to be a code. Okay? Except this is a dedicated circuit. It's not blue. This is not a code. I will use the green for non-code. Do I need a dedicated circuit? No, I don't need a dedicated circuit. Light. Yes, sir.
What's the other opening in the garage?
I think this goes in the house. In the house. Is that, yeah, I believe this is a door inside the house. It's detached garage. Okay, then I'm going to highlight in blue what's code and green what's extra. What's code 2, you need one light. Do I need 3 lights? No. One light is enough code. And extra, what's extra? They have another light extra. These are extra. For the light that you need in the garage, you need at least one switch. This is code. You need to switch it, right? I need one switch. All the 3-way switches that they're having here, oops, for, let's see, what did we say? Yeah. So this switch, I'm going to call this is my one switch at least. This is my code. The blue is code. One switch at least, but they use the 3 and 4-way switches. You're switching it from 3 locations. Overkilling, maybe. Good idea? I think so. You can turn the light from the garage from service door, from the door to the house, and also from the car door, or whatever you're gonna call this one. Okay? Also, these are extras. Aren't these extras? Don't you guys think that these are extras? Do I need them? How about this right in the middle of the yard? A light, right? Pole-mounted light. These are all extras. Good idea. I think so. Makes your if it's my house, it's a good idea. If it's DJ's house, who cares? You know, I just go give him that blue things and move on. Cheap, dirty, right? Okay, can you guys see that? Now, another thing. Do I need a garage door opener?
No.
By code, as far as the code concerned, you can have you don't have to have a garage door. You know, is there a building code where you have to have a garage door? You have to have a door for the garage. I think it's a building code to have a door for the garage, but it doesn't have to be powered. It could be manually powered with my muscles, right? Take them down and up. So this is, as far as the code concerned, this is an extra. If you have a garage, here's where it becomes a must. If you have a garage door opener, then you have to have a receptacle for it. A receptacle. Does this receptacle to be in a dedicated circuit? No. Could it be fit from any other circuit? Yes. Is it a good idea to bring one circuit and feed the stuff in the garage in one circuit? Yes. If this is your house and you're welding and melting and doing all these, making a shop, is it a good idea to have 240 plugs? A lot of people have guys welders and compressors and all this stuff. A lot of people have a panel here, you know, and a panel, and they can wire a 60 amp panel, and they wire a lot of switches from it, and 240 plugs for their compressors and their welders and all this good stuff. Any question about this? If you're concerned about these two outside lights, they actually have them, if you remember, on a switch inside the house. So, is this the only way of doing this business? No. What they recommend in this book, and I agree with it, guys, two things. Look where the lights are located. You're going to put, if you cut your garage by half, your lights are going to be in the upper half or the furthest half from the door. Why? Because if you don't want your lights over here. So when you open the garage, the light will be right above the garage, right? The garage door. So this area will be dedicated for the garage door as you pull the garage door. So they want you to move the light to the back. Number one. Number two, another recommendation is your garage have to have one light more than the cars that you can fit in this garage. For example, if it's 1-car garage, 2 lights. If it's 3-car garage, 3 lights. 4-car garage, if it's a 3-car garage, 4 lights. If it's 4-car garage, 5 lights. 1 light more than the number of the vehicles that you can fit, not including the lawnmower or the snowmobile. It's a full spiel, complete vehicles. Does that make sense? Is this code? No. Recommendation? Yes. And the idea is, guys, if you have one fixture, and I really agree with that one, if you have one fixture and it burns in the middle of a winter, it'd be pain, you lost completely light in there. If you have kids, people who have kids, you understand that one. When you're trying to load them in a car and there's no light, it'd be really tough. Okay, here's what we said, guys, about the 2, 3, 4 versus 1-car garage, 2-car garage, 3-car garage. And look at that, position the lamps to minimize the shadows between the automobile. So if my Mercedes is sitting, all my Chad's Mercedes are sitting here, you probably situate the light somewhere in between them, not right above the light. See where we situate the light, right in between them in this area. So the shadows. Recommendation. If you don't care and you live in the wilderness, you don't care about the garage and the power at all, even. Don't cover it by the door. Keep in mind when you place it, not covered by the door. Okay, doorways. Fluorescent. Again, you can argue with this one. We hear this one all the time, especially in Minnesota. They're not recommended. Fluorescent lights are not recommended outside. I use compact in my garage and they work good. But the fluorescent long tube, they might not start if it's too cold. That's the only reason. Not good recommendation. Any question, guys, about this? So straightforward, no gimmicks, nothing. We talked about the one receptacle, right? At least one receptacle. Here's where in the code it says one receptacle, right? And it says it has to be GFCI protected. And if you don't believe Chad, this is where it tells you that receptacle has to be GFCI protected. Unless, what if you have a 240 40 amp welding plug? Does it have to be GFCI in the garage? No. And that's where this becomes a big deal, guys. 15 and 20 amp circuits. Only 15 and 20 amp circuits, and only 120 volt. If you have a 208 receptacle or 240 receptacle, 15 and 20 amp circuit, does it have to be GFCI? No. Because if you're smart enough to know to use a 240 20 amp receptacle, you're smart enough to protect yourself from GFCI. That's kind of the idea. And nobody's gonna plug, a TV and a 240 20 amp receptacle. All right, garage door opener, garage door circuit. Most of you guys are very familiar with that. Garage door opener as a complete standalone set. There's a really nice picture of it. Complete standalone set. All what they need us, Mr. Boo, the only thing they need from us is just a plug. Just plug it in. It's made out of two parts. The power part, that's power a motor that actually opens and closes the garage. That's part one. Part two is the control system, and they use what is it, number 16, I think, number 16, two wires, number 16, and they wire the push buttons and the controller from them. And they have a nice picture of it. So there's low voltage 24 volt part of it. There's the 120 part that's coming to the motor. And there's also the controller. There's a controller inside it, and this is the 24 volt that controls the motor up and down, and safety switches and so forth. Yeah, I have a couple of nice pictures of that. Low voltage outdoor. We talked about, guys. So that's basically for the garage. Any question about the garage? We'll have a couple of nice pictures about the garage door opener. Landscaping. Most of the landscaping stuff, I'm going to tell you this real story. How do you start with? Real story of my neighbor was doing landscaping, and he bought the landscaping from Home Depot. And every time he buy it, he put the landscaping was supposed to run at 240, so he connected 120 across the 240, burn it. Every time he puts, he go burn the stuff. Burn it 3 times, send it to Home Depot, until he asked me, finally, he said, Chad, I must be doing something wrong. He was bringing his 24 volt, he bringing 120 on it. You burn it, you bring a 120. Most of these system landscaping, guys, are low voltage system, 24 volt or less. They come with an isolated transformer for safety. Their lights, the isolated transformer. Everybody knows what an isolated transformer is. Here's a transformer. From this side, you bring 120 volt, no ground. From this side, you get you a 24 volt. That's called isolating transformer. And then you bring your lights here. There's some controller with it. And you plug them in, and all these landscaping light comes on. Isolated transformer, no ground here on the low voltage side. And now for safety, if it's grounded, then if you touch the 24 volt, guys, the hot, the system is not grounded. That's isolated, so there's nothing will happen to you. Anybody want to try it? If you have a Delta system and you grab phase A and you stand and you sit in a swimming pool, nothing will happen to you. Phase A, hot. Grounded, non-grounded system, no problem. That's why they have it, non-grounded system. The minute that you ground the system, then you got into issues. So that's why they have a call it isolating transformer for safety. And of course, if the controller and the transformer, guys, are listed outside, then they have to be, if they are to use outside, they have to be wet location. Yes, sir. Not me.
I'll do it.
I know it doesn't. You do it, Ben? Anybody can volunteer an animal for us? Now the tree huggers are going to be in trouble. A stray dog, neighbor's chicken. Here's what we're talking about, guys. 24 or 12 volt, you can find this system is a 12 volt system. Here's my transformer, 120, 12 volt, isolating transformer, and you plug your lights, no problem. The only thing is everything has to be cover proof here, weatherproof, as you plug them in. As you plug the plug, it has to be completely encased. Yes, sir.
Where does that transformer usually get located? In the dumbbell panel? Downstairs?
Come on, buddy. 1 second, let me just dismiss. Okay. The transformer, this transformer could be sitting outside too. Could be if it's weatherproof. I've seen them where it's right next to the equipment. You plug it in.
But isn't is the doorbell 24 volts as well, or is that 48? Remember I told you how I see transformers sometimes in houses in the basement?
Oh yeah, that's 24 volt for the transformer, right for the doorbell. This no, completely different. This is a completely standalone transformer, isolated inside it, plug in for safety. Does that make sense? You can't put this transformer in the room and the plug outside, because then this cable have to go through a door, and these are they're not rated for wiring. These are extension. They're cords. The idea with cords, guys, I can't drill a hole from here and take this cord through the hole and plug it into a receptacle on the other side or through a door. Cord, you're not allowed to. This is not permanent wiring system. So long story short, this piece of equipment will be right next to the plug. Any question, guys, about this landscaping? If anybody wants to do landscaping, GFCI protection, obviously. The circuit that feeds the circuit, this has to be GFCI. You guys agree with me? It really doesn't matter. It's an outside receptacle. An outside receptacle must be GFCI. So it has to be GFCI. So the whole system is protected from GFCI. You don't have to provide a special thing for it. You can use a UF cable for it. UF cable. The cheapest way of moving in residential between point A and point B outside underground is UF cable. UF cable, you can bring them, you can buy them. Number 2, number 14, or number 12, or number 10. These are 2 or 3. I believe they go probably also 3 number 3 and 2 number 8. So you can buy 3 conductors, number 12, hot, neutral, and a ground, not including a ground. The ground is always ground with them, plus ground. So you can move, if you have hot 2 circuits and a ground and a neutral shared circuit, no problem. The cheapest way of moving through it. A couple of things, guys, if you look at this picture and you have it, if you want your conduit to carry the weight, if you want your conduit to carry the weight of the box, they want you to have 2 conduits. There's some exception if it's rigid, but you can't have 1 conduit sticking and carrying a box. And if you guys read through them, it says the last one, rigid metal conduit, intermediate PVC, schedule, and electrical metallic tubing. Conduit bodies may contain splices, blah, blah, blah. So they want you to use multiple 2 conduits at least. Conduits that do contain wiring devices shall have threaded, blah, must be supported by 18 inches. Only if the entry or the hub on the conduit is not. So long story short, they want you to bring 2 conduits. If it's just sticking, guys, if the box sticking up in the air like this, it's not supported in the back. If there's a wall behind this box, who cares? The box will be supported from the wall. So there's some restrictions. You can use rigid, intermediate, PVC, and EMT. Keep this in mind as you wire your system. We all know that UF cable is, you can, no problem, direct, can I put Romex in the ground? I can't put Romex in the ground. Not legally. Huh? And PVC. If I have my favorite oak tree that I had my first date under, oops, did I say that? And I need to have a light to celebrate my my 1985 date under that oak tree. Can I put a light? Can I put a light, attach the light to this tree like this? Is this legit by code? Who says yes, who says no? How many of you guys say yes or no? Yes, it's a support system. It's a support system. We're not using it as a wiring system. We're using the tree as a support system. So you have to protect from physical damage. So you bring your cable 18 inches down here, direct buried, then up to 18 inches, you put it in a conduit, schedule 80 PVC, and you go all the way up to the schedule. This will be PVC schedule 80, and inside it there will be wires rated for wet location, and you put your beautiful light, and you have your party DJ with a keg. No? Shouldn't say that. So this is okay. This is legit. Here's what's not okay. Now instead of buying yourself a pole to wire your shed in the back of your farm, you use these pine trees that God created for us as a transmission line, right? Pine trees as a support system for your wiring system. This is a no. But the light attached to one tree, no problem. This is, guys, violation because you don't want any wiring system. You can't use the trees as support for your wiring system. For a fixture, okay. I can't. This was in a test, guys. Is this okay? One fixture, yes. Now, if I grab, here's another tree here, and this is where DJ has his first date, and he said, "Can you wire a lighting fixture for me, Chad?" Here. Now, roll. This is a no, right? What happened? I just disappeared it. This is a no. Huh? The wiring? Yeah, that's. You can do anything you want. You can use barbed wire if you want to, but it's not good. There's nothing wrong with that using Mother Nature, if you ask me. But they just don't want you guys. And for safety issues, if you climbing trees and so forth. This table 3, this is table, what's the number of the table again? 300.5. 3.5. I want you guys to look at this table, please. This table, we looked at it before. This is very important for not just residential, every application. Mr. Boo, my friend, 90% of the engineers, you're going to be, usually when we put our conduit, we specify 24 inches. 24 inch. That's where you're going to find commercial, industrial. A lot of people, guys, when they have conduit system, they always specify that 24 inches. Dig that trench 24 inches, put my conduits down there, and bury them at 24 inches. So direct buried cables or conductors, minimum depth unless otherwise. So all other locations, if you guys look at this table, this is for all other locations. If you use rigid, rigid or intermediate, they allow you to use 6. If you're using 12 inches in residential, this is very special for residential. 12 inches. The requirement for 12 inches residential, number 1 residential, number 2 20 or 15 amp, number 3 the voltage 120, and number 4 GFCI protected. They allow you to go 12. Number 18, if you have non-metallic raceways, direct buried like PVC, you can go all the way to PVC to 18. As I said, the most important ones in commercial industrial that we use was the 24 inches across the board. We bury our conduits and move on. But this cable is really interesting as it goes through a lot of situations. So 24 inches. So if I have a UF cable, in residential protected by 120 amp GFCI circuit, UF cable in residential 12 inches. If I move the same UF cable or any cable and to a commercial building, UF cable, and I need to bury it, direct buried, no conduit, nothing. I need what? 24 inches. 24 inches. Everybody knows how to read this, guys. This is the first column would be for all other applications, and there's a few exceptions. We'll go over them as we go through the year. And as you bury your cables, how are you going to bury your conduit cable, guys? Right now, the ones we use PVC, schedule 40 or 80, direct buried PVC, schedule 80. Which application apply to us? We're not like when we did the swimming pool. There's no GFCI. We didn't take a GFCI circuit to the swimming pool. We have a GFCI receptacle there, but the circuit itself is not GFCI protected. So which application will apply for our project? Which depth? Let's think about it. Can I use this exception for residential? No, because I didn't put GFCI in the building. I can't use it. Can I use this? Am I using rigid? No. Can I use this? What does it say? Non-metallic raceways listed for direct buried with not enclosing concrete. That's what we use, right? We use PVC. We use PVC schedule 40 with conductors inside it. So that applies, the minimum applies to us. What I always suggest, guys, is to go with this, with 24 inches. But we can get away with 18 inches, 2.5 feet, 1.5 feet. So this is the applicable for our project.
Why can't you do fire protector?
Huh? Well, you can if you want to put, like, look at the sump pump. Not the sump pump, the swimming pool pump. You're going to put a 30 amp GFCI in the building for it to protect the whole circuit. The heater, you're going to have another 25 or 30 amp for the heater.
Plus, second garage.
Oh, the garage. You can if you want to put this circuit. You can put the. You can if you want to put a GFCI circuit breaker inside the building that feeds them, and they are all of them are 120, 20 or 15 amps. Yes, you can if you put GFCI.
So that would be considered residential, even though
It's residential, apartment residential. Okay, any question, guys, about this table? Really cool. The only thing I want to go show a couple of pictures here before number 16. We got the wiring here. Here's the garage, how they lay it goes, 2, 3, and 4 for how many garages. You can use different type of fixtures. Talk about that one. Wiring with ground. We talked about these. This is interesting. I want you guys to look at that one. Can I use the neutral as an equivalent ground conductor? Here's a pole light. The code says, guys, if here's a hot, here's a neutral. Long story short, without you need a neutral conductor that comes from here and ground the pole. And this is my ground. You can't take a 2-wire cable to a light or anything outside and it depend on Mother Earth to return the current. So some of you will say, Chad, this is a pole grounded right here. And I tie the neutral to the pole here. Long story short, if you have structure, anything outside, guys, you have to send to it hot, neutral, and ground. You can't just send hot, neutral, and bond the neutral and the ground on the other side. So this is, sending the light over here. You have to have a grounding conductor with it. That's all what you need from him. Hot, which we always do, hot, neutral, and ground. Hot, neutral, and ground. Stuff that then. Conductors. Couple of installation. Do I have to provide a grounding rod with these? This is, guys, if you have a light, you have to provide, long story short, the only thing I want to remember, all these you need a hot, you need a neutral, and you need a ground. It's the only thing you need to remember for all these lights. You can't just bring hot and neutral and depend on the ground to ground the equipment. It's all what you need to remember. UF cable, There's a couple of, this example, guys, will tell you how to transfer from a UF cable all the way to get into the building. If you're coming from the outside, that would be a situation where we are in. So we have a UF cable right here. Our UF cable come here. You have to protect it for 18 inches, and then this have to be protected EMT if it's not severe physical damage, or PVC schedule 40 if it's not severe. Elbow it and come right into the building, right into the building. Or you can go direct like this, guys. But if you go either way, you have to insulate here. Either way, you have to insulate. Every time we go from one temperature rated place to another temperature rated place, you have to seal them because of temperature variation, right? The temperature here could be 0, and the temperature here could be what? 72 degrees. So you have to seal them. Physical protection for the cables, and seal as you enter the building. That's typical for all wiring, guys. The question is, do I need a ground rod to ground rod this building here? No. The pole, do I need a ground rod with a pole? No. Can I put a ground rod with a pole? Be my guest. You don't need it. A lot of parking lots, guys, sometimes they put ground rods with the parking lot lights for lightning, not for grounding, because you already have a ground. You should have pulled the ground with it. Garage door opener, plugged in garage door opener. Sometimes with the garage door opener, guys, they have a fuse, the switch. By the way, just FYI, your garage door is also a motor, need a disconnect. So if it's either plugged in, if it's not plugged in, then you need a disconnect. How do you hardwire? Never seen them hardwired. Anybody has a garage that's hardwired? If it's hardwired, then you need a disconnect. Here's your switch, here's the disconnect. And sometimes they put a fuse, secondary protection, no problem. You can put a fuse, no problem. But what I want to, hardwired commercially, thank you. But you still need disconnect. Here's a controller, guys. Very simple. This is the power coming here to the motor. This is my 120 volt. And then from here, you transfer it to 24 volt to a transformer, and you get your push button. You push that, you start the controller forward, reverse, and a whole couple of push buttons, a couple of sensors for safety. You guys have seen the sensors. So with the garage door, you're going to have a keypad, wired keypad. You're going to have a couple of sensors. You know, that eye sensor that goes. All these wires are going to be connected. And what else do you have? You might have 2 keypads, or most of the time you'll have 2 keypads, 2 wires. And all these wires, guys, are coming where? To the controller. Inside the controller, there will be control to turn the light on. That comes with, it's all complete system. You can turn the light on and off. You can lock the garage door opener. There's a push button, you can lock it. Garage door opener, you can open, close. These sensors, as you get the safety, you can't close while a child or somebody else is walking through the garage door. You can't lower it, right? It's supposed to go down, and it hits an object. It goes up immediately if you break this line of sight, for this laser light that comes over here, right? All this stuff comes as a complete system. This one, as we all know, guys, comes as a complete system. The only thing we get involved in directly is providing 120. Can you troubleshoot this system? No problem. Bring it on. It's all 2 wires. All of them are 2 wires. Going to the controller. If you guys have the, Chanel, my friend, if you have the wiring diagram for this, and if this is not working, these sensors, you can easily go change these sensors. Really, not a whole lot. Adjust them. Adjust them we do all the time, but change them. And new sensor. You can go troubleshoot if they're not working. If you have the wiring diagram inside here. Not a whole lot. It's just a complete standalone controller, custom design. Anybody knows what type of wire is this? Here, what type of control? This will be class 2 circuits. Controls, class 2 circuits. or depending on the voltage, or class 1 or class 2 control circuits covered under Article 725. Article 725 cover control circuits. We will be coming to it. So everything is electrical is us, man. You're not getting away from it.
What is that, 7-1?
725. Okay. This, they will tell you guys also a supplemental overcome protection device is recommended here. Supplemental overcome protection device. You don't have to. Fuse, an inline fuse. Not a biggie. Okay, and DJ, you're gonna do this wiring for us. Not now though.
Oh, why?
Well, I just don't want to do it at this time. I want to go to the next chapter. I'm going to give you guys 4 more minutes. I'm going to go one more chapter and then let you relax, because I really need to go over the track. If we have time, we'll pull one of these and we'll do the wire point-to-point wiring, while the rest of you will enjoy the day. All right.
Chad, were you there?
Oh, I wish I was there.
Where is that? It's on your photos.
It's cool. I wish I was there though.
We wish you were too.
Thank you, DJ. Okay, recreation room. Last chapter, recreation room. I know I grilled you today.
Define something as a rec room.
Recreation room. It's usually you and your wife. You can define a room. What's the difference between a family room and a living room?
One's got toilet.
People get richer in America and they start adding more rooms and adding. We used to have one family room, man, and now we have family room and gun room.
Farm hall.
Okay, let's go to recreation room. The only thing I care about, Chanel, my friend, is it is a habitable room. I don't care what you put in it, your plasma TV or your computer,
Or your aquarium.
or your printer. We're going to talk about the multi-wire branch circuit. You're going to get sick of Chad talking about multi-wire branch circuit, guys, from now until the year, because it's very powerful, very important. I have a couple of good examples about it. In a recreational room, some people like to have a lay-in fixture. You're looking at it right there above you. Fluorescent lay-in type fixtures in a false ceiling or suspended ceiling. And this chapter, if you guys please read it, it has a nice examples about voltage drop calculation for 2-wire and 3-wire multi-wire circuit, 3-wire and 2-wire circuit. Long story short, this calculation, we did a lot of them yesterday, guys. Was it yesterday when we did the voltage drop? And when you're dealing with 240 voltage, you can push that 240 voltage longer distances versus dealing with 120. So that gives you an advantage. If you have a multi-wire circuit, it gives you a lot of advantage, and voltage drop is less. One conductor is less. If your voltage drop is less, also your losses in the lines is less. You don't have a lot of losses. So that's what we're going to be talking about, my friends. Fixture width, that 6-foot or less piece of wire that you attach to the fixture from one side to a box from the other side. It's we'll talk about this one. Multi-wire branch circuit advantages. And what happened if you disconnect a neutral like Chad did a couple of years ago? You burn stuff, right? That's it. So you guys you're done with the chapter before we even start. Okay, here's their so-called recreational room. Look how they have a 2x4 fluorescent lights, 6 of them. That's an overkilling, right? 6 of them. Look, let's see what they did, guys. Let's by the way, let's talk about the code. What does the code say here? The code says you need 1 light with 1 switch and a receptacle layout. What's a rule for receptacle layout? 6x12. That's it. 612. That's the only rule. I think they went overkilling here. Definitely, this is not 12 in between them, right? So they went nuts, banana. They start throwing receptacles all over. Let's go track the light, guys. Let's track the light. Here's a circuit. They brought a circuit B9 and 11, two circuits. They have a multi-wire circuit. They're bringing a multi-wire circuit, B9 and B11. Why 911, not 910? They have to be two adjacent, consecutive odds or even. So you can't put an odd and an even. Either two odds, two evens, and they have to be consecutive. So 9. Why? Because that's how it's 1, 2, 3, 4, 5, 6, 7, 8. That's how we capture the 240. You can't capture a 240 from 1 and 2. 1 and 2 are the same odd. If you tie them together, this is 120. Okay, so we'll talk about this one, guys. Let's talk about the lighting circuit first. Look at the lighting circuit. They brought one lighting circuit only, and they fit all these lights, and they have a switch over here that turn all these lights 1, 2, 3, 4, 5, 6. These are fixture with fixture whip attached to a J box, no problem, Chad, and controlled from one switch. Okay, so that's the first circuit. Then the second circuit, they brought two circuits, and they're feeding from these two circuits. They took one circuit here, and they're feeding, I believe one circuit is taking and feeding 1, 2, 3, and of course with this 4, and they stole the power to a switch, and they fit two closet lights here, whatever that area is. So they fit it from this receptacle. So that's my circuit number 1. From the other side, they grabbed, I believe, another circuit, and they went and fed. Is that what they did, guys? They fed. You can't tell just by doing, and they fed these two receptacles. There's another one here, a third one here, and they stole a fourth and a fifth, and they stole. They have a switch here. I believe this switch is to switching these two receptacles as switch receptacles. They have no, wrong, Chad again. These are hardwired, right? Here's 1, 2, 3. What do you think this receptacle switching? 1, 2, 3, and 4. Switching these cans. They have a switch here. What do you think this switch is? Coming all the way to the fan. So they have two multi-wire branch circuit, guys. Distribute the receptacle and the light in between them. Any question about that?
Who designed that? You?
No. Do you think it's overkilling?
I think the 4 cans right there. Sure, I'm gonna put this.
The 4 cans. Hey, it's people wants their homes to look good. What's wrong with that? Are you paying for it, buddy?
No. That much light, you better keep the place pretty clean.
Yeah. So that's basically the recreation room. They have a lot of issues. They have the money to spend. But these are 6 of them in one room like this. It's a little bit overkilling, but hey, it looks good. You can dim them. I think they're on a dimmer too. You can dim them. Any question, guys, about the circuit? So multi-wire circuit feeding the receptacles, another circuit feeding the lights, and they're stealing some from the multi-wire circuit and feeding some receptacles. Any question about the layout? Code-wise, all what we need code-wise, guys, for this recreational vehicle, you need 4 receptacles here. You need the rule 6-12 rule. We're all familiar with the 6-12 rule, and you need a light with some type of a switch or control. That's all what you need. Everything else is extra. Okay, lay-in luminaire fixtures. How many of you guys installed lay-in luminaire fixtures right above you? Lay-in in a suspended ceiling, hundreds of them, right? They call them lay-in in a ceiling. They have to be suspended ceiling grid, like right thing above your head, and you lay. They are laid. They call lay-in fixture because they sit firmly against these frames of the grid of the ceiling grid. A fixture web. I think I have a fixture web, a piece of wire with a conduit with wire or a cable attached to that fixture web, to the fixture, and from one side, from the other side, you go attach it to a J box. Why do we attach it to a J box? To wire it. Do you want to bring an EMT directly to this fixture if it's suspended in the ceiling? No. Why? There's no vibration here, but you can't move that fixture. You can't move the fixture. And for those of you who guys want to install it, there's a special clips that you clip them, so as you move them around, they're not going to fall right above my friend Spencer, as you maintain them, because they're not, you have to clip them to the bars of the ceiling grid. For safety, because you don't drop them. Here's what we're talking about, guys. You lay it right on the frame. Here's a fixture web. Fixture web in 2011, 2008, the code requires fluorescent lights that has two-ended fluorescent lights to have, not one-ended, two-ended fluorescent lights to have a disconnect. In a situation like this, guys, then if you're a fixture web, you need a switch here. You need a switch.
Well, they have those things now where you
Yeah.
can break it.
They came in many applications. So here's a fixture web, but it has to be fixture web 6. Here's the definition of fixture web: 6 feet or less. No, it doesn't have to be 6 feet. It could be 25 feet if you want it. Most of them come with 6 feet for a couple of reasons. Reason number one, 6 feet or less, you don't need to support the cable. So the cable can be laying on.
A lot of cities you do that.
Yeah, they force you, unless you have an ordinance, unless the engineers say otherwise, code-wise, thank you. Code-wise, you don't have to support it if it's 6 feet or less. Number two, you can use the shell of the flexible metal conduit, if that's what your web is, as a grounding means. You don't have to pull another conductor if you're using flexible metal conduit. You can use hot neutral, and the flex itself will be your grounding means if it's 6 feet or less. So these are the application. And the fourth advantage of a flex tool, 6 feet, any flex, is flexibility. Allows you to move the fixture, adjust it, and so forth. So can I have a 25-foot fixture web? Bring it on. What's the only difference is, now you need an independent equipment grounding conductor. If it's your flexible metal conduit. If it's an MC cable, you already have it. If it's an AC cable, you already have it. And also you need to support it every, what is it, MC cable every 4.5, I think, or so forth. Fixture web, here's the most common with fixture web, guys. You have an MC cable, AC cable, flexible metal conduit, flexible non-metallic conduit, if I spelled that right. Anything that has flexible, could be a cable or a conduit. If it's a conduit, what do you need in a conduit? Wires. If it's a cable, do you need a conduit in the cable? A conduit in the cable. Do you need wire in the cable? It's already come a symbol. Okay. We'll talk about multi-wire branch circuits in terms of, here's a multi-wire branch circuit, guys. Multiple lights. I want you to look at the disadvantage of the advantage of multi-wire branch circuits. We all know, save money on installation, save one conductor, voltage drop less because now you're using 240 to push the current versus 120. And if your voltage drop is less, guys, guess what? Get less losses in the system. Disadvantage, if knucklehead Chad Curdy or DJ went and accidentally in a EJ box disconnected the neutral. Now the equipment is exposed. This was rated for 120 here and 120. Now all of a sudden they're sharing what? They're sharing a 240. And if you have, when you learned with Mr. Ryman, series circuit, which we don't like in the power industry that much, when you have two power loads or lighting loads connected in series, what do? They share the voltage. They share the voltage based on proportional to their impedance, meaning the fattest, biggest impedance will take the largest amount of voltage, and the skinniest, smallest impedance will take the smallest amount of voltage. Long story short, you're going to end up with, in this case, look at this one, end up with 109 volt, and this one will end up with 130 volt. No problem. If it's an incandescent lamp, had these been incandescent lamps, guys, you're going to see two things. This will dim, and this will go brighter. Had these been a motor, and a motor, one of them is a motor, one is the light. You know, the light is going to hog most of the motor, so it's going to get, say, from the 120 is going to take 100, the whole 120, it's going to take, let's say, 80% of the volt, and the rest of it, which is leftover is 40, is going to go across the motor. The motor is going to start sucking more current out of the system to compensate for the low voltage, More current, what does more current means? Heat, start heating up, and all of a sudden you start smelling, bad smell. And if you don't recognize it, smoke start coming, and if you still don't know what's going on, fire will catch up. Eventually you'll short the ground. Eventually when there's fire, you'll short the ground, and eventually this guy will wake up, open, trip, melt if it's a fuse, but not before fire is raging inside your house or basement or whatever. It's a big deal. Disconnecting the neutral, big deal. If you guys are wiring things, I always say, be very, very careful of opening any neutral. Very careful. You see the bunch of hot conductors under one wire. The first thing when you look at them and you want to tie another white conductor to them, always think one of them could have been a multi-wire circuit. If I disconnect them like Chad did, I could have burned something in the house. So that's always, always. So the way they do it, guys, to do the calculation, look at that. This one is, first you need to find R to see how much voltage is going to be across them. You're going to need to find R. So here's E over 12. That will get you the ohm for this fixture is 10 ohm. The ohm for this fixture is also 12 ohm. And then you multiply the current that's go through them, and they will be divided. Between these two fixtures. The voltage will be divided between these two fixtures. The way we do this calculation, guys, is to find how much voltage each one of them will get. You start with, so if you have an equipment, it has watt or volt amp and voltage. From the volt amp and the voltage, I can find the R. What's the R? R equal V squared over P. This is from Ohm's law, right? V squared over R equal power. So the first thing, if I want to find what the resistor of a load is I always find V squared over R. This will be a piece of cake, guys. Say this equipment, this was a motor, and the volt amp for this motor was, let's just say 400 here, and it was running at 120. All right, let's find the R for this. Okay, piece of cake, Chad. Here's 400 to the power 2 divided by 120. Who's my calculator for the day? 400 shift square divided by 120 equal. How much?
3.
I have 1,330.
Oh, squared.
Power.
400.
No.
Oh, the power.
Is 120.
Oh,
Not 400.
I did that. Thank you. That's what it sounds. Thank you. I'm glad one of us is awake. So the 120 to the power 2 divided by the 400, because the power at the bottom. So we're going to take 120. That's why it sounds 120 inverse squared equal divide by 400 equal 36. Anybody came up with more than 36? So this is a 36 ohm. Okay. Now, had this motor been here, this will be a 36 ohm. And then, say we have another motor connected to it, and this motor was rated for 600 volt at 120. I need to find the impedance of this piece of cake, R2. This is R1, R2 equal 120 to the power 2 divided by 600. Let's do it again. So 120 shift square equal divided by 600 equal 24. This boy is 24. So this is now a 24. That's how you start by finding the voltage, guys. Because when you lose the 120, you have no idea how to find the current. If you have two loads, multi-wire branch circuits, and you disconnect the neutral, and you need to find how much voltage each one of them will take, the first thing you need to do is you need to go find the resistance of each load. Very easy. Take the voltage square divided by the volt amp of that load. You have to have the volt amp of the load and the voltage. Okay, now looking at them, you guys are very smart, sharper than my grandma. If you look at this and look at this, which one is just by looking at them, 36 and 24, which one of them do you think, looking at it without doing any calculation, which one of them do you think is going to take more voltage? The 36. The largest, fattest impedance is going to take the huge amount of the largest voltage. So if we quick do the calculation, guys, for it, if you want to find I equal, what's the voltage? 240 now, divided by, add the two impedances, at 24 plus 36 equal 240 divided by 50, 60, right? 60, that will give you 24 divided by 6 is what? 4 amps. I love it when you guys are so with me. 4 amps. Now the whole circuit, 240 circuit, is carrying 4 amps each. So I have 4 amps coming from here and 4 amps coming from here. 4 amps, 4 amps. Okay? Now let's find the voltage. If I know the amps, now I can easily find the voltage. Let's take V1, which is right here. This is V1. V1 equal I is 4 multiplied by 24 by 36. 36. Can you guys do that? How much? This will be 144 volt. 144 volt. Let's do the second one. V2 equal 4, the same 4, because it's series circuit, multiplied by the impedance of it, which is 24. What would that give you, Brad? 96. 96 volt. Okay, now let's look at it. My beautiful motor, air handling unit, or let's say just a pump, that's supposed to get 120, landing 96. Motors are dumber than rocks. And instead of saying, now I'm going to give you 96 worth, I'm going to proportionally reduce my power to accommodate for the voltage. They don't, Spencer. They start sucking more current out of the system to give you the same amount of power. So long story short, this will burn. And if this is equivalent also with the motor 144, this will burn because of over voltage. You get over voltage in that. So you get fire. Most likely the one that has lower voltage always burn, because start sucking more current. More current is higher voltage. So you burn your equipment. Does that make sense? Do you guys know how to do the calculation? If you lose a neutral, always find R. When you find R, now you have two R's in series with each other. They're sharing the voltage proportional to their impedance. The highest will take the highest amount of voltage. The lowest impedance will take the lowest amount of voltage. DJ, if you don't know this, we're going to send you directly back to Mr. Ryder. Did you meet Gary? No. No? We have to send him one day there. Okay. So that's basically it, this calculation. Then it gets into the voltage. This calculation, you guys will read through them. I don't want to go change it into a calculation. Here's what I want you to tell. If you're using a multi-wire circuit, here's what I want you to understand. If you're using a multi-wire circuit, voltage drop equal 2 times kil, K-I-L over circular mil. Okay. Now, the reason why we have two is, because the current go and come back. If the current doesn't come back, then we don't need the 2. If you're using multi-wire circuit, this will change into K-I-L over Cm. What happened to the 2? In a multi-wire circuit, the current here, 1, 2, 3, this will carry 0 current, 0 amp. So here's a 10 amp here, and a 10 amp here, and this one, most likely, a multi-wire circuit will carry very small to 0 amps. So that's one way of doing it. So you drop the 2. What happened to the voltage drop then? Dropped by half. You drop your voltage by half. Or you can use the same thing, 2 KIL over Cm. And when you use the voltage that you're using, use the 240 volt. What does that mean, Chad? 3 volt, voltage drop 3 volts coming from 120 is completely different than 3 volt coming from 240. I mean, if you take 3 voltage, if we came up with 3 voltage drop, not 3, just say if we came with 5 volts, 5 divided by 120 equal, give me 5 divided by 120, give me 4.1%. But take the same 5 divided by 240, that will give me 2.1%. Cuts it by half. So that's what this example guy is trying to do. Is trying to, when you do the calculation for it, use this formula if it's a multi-wire branch circuit. But here's the problem though. If it's a multi-wire branch circuit and one circuit is landing on one switch and the other circuit is landing on the other switch, what happens if one part of the circuit is on and the other part of the circuit is off, right? Then you will be in a situation, guys, where there will either one situation where will be the current going both direction because one part of the circuit is off.
You know, the arc bulbs can eliminate multi-wire branch anyway.
Unless you want to use I'll do the Photoshop. Unless you want to use the a 2-pole arc flash.
Don't have them.
I thought we
No,
searched that
they
one.
didn't work. They're totally.
Did they?
I contacted the rep for.
Okay, then that will. But in residential, we still have the whole commercial, right? Still the whole commercial where you don't need.
Right. Yeah.
Okay, using a multi-wire branch circuit, guys. I'm going to respect your lunchtime. Using a multi-wire branch circuit, here's the 3 advantages of using it. This wire, we know why. Instead of 4 wire, now I have 3 wires. I can pump the same amount of power with 3 wires versus 4 wire. That's good. Low voltage drop, we know why, because the current goes and never come back because they're balanced. So I cut it by half. And power losses, guys. If you have, let me just tell you a little bit. There's calculation there, you can use it. If you have, here's a 10 amps here, and of course the 10 amps are going to come back here, non-power. And if the resistor of the cable is 0.0, it's just 0.02 ohm. 0.02 ohm, okay? And I need to find the power consumed in this cable, and the length of this cable from here to here, say 100 feet. 100 feet. And this is for every 1,000 feet. It's a 0.02. You get it from table. This is what we got from table 8, guys. You can go find that ohm from table number 8. They give it to you in 1,000. So I need to find R. Here's an R equal 0.02 multiplied by 100. Why 100? I have 100 feet of them. Divide by 1,000. 2 goes with 2. That will give me 0.002. Right? Am I right? 0.002. So the resistor of this cable, one direction, is actually 0.002. So let me find the losses. It's not a big deal, but so I know that there is a 0.002 ohm here and also a 0.002 ohm here. Again, this value, you can find it from chapter 9, table 8. And we've used it, guys. Why did I divide by 1,000? Because these are always given in 1,000 in the table. Let's find the losses. Losses in power equal I squared R. What's the I? 10 to the power 2 times. What's the R? 0.002. So 100, that will give me 2 or 0.2. 0.2 watt. Did I do that? 100 multiplied, 0.2 watt. Right? 100 multiplied by 0.002. Shift it to, that'll give me 0.2 watt. Now, if you have a multi-wire branch circuit, you stop right here. That's it. If you have a multi-wire branch circuit, that's all what you have. If you have a non-multi-wire branch circuit, meaning the current goes and comes back, then you multiply this by 2. Why? Because it goes and comes back. So it will be 2 times 0.2 equal 0.4 watts. This is for a hot and a neutral circuit, which is non-multi-wire branch circuit. Who cares? Add guys how many branch circuits you have in the commercial building, and see that 0.2 multiplied by 2 if you don't do it, and how much you can save. You know, over thousands of branch circuits in a big building, that could be a saver. And what happened with these 0.2 watts? They're heating the conductors. They're creating a heat for you. Our friends, the HVAC guys, they love it in the winter because it reduces their heat, right? Consumption. In the summer, what happens? It increases their cooling system. So, any question guys about this? Straightforward, no gimmicks. The key point, if you have multi-wire branch circuit, you drop this 10 amps coming back. It's just one way. We talked about the neutral, burnout, ground fault circuit interrupter also is needed for all these equipments. GFCI if it's within a sink. If you have a recreational vehicle, you have a sink bar, you have to have a GFCI. Otherwise, all arc fault circuit interrupters must be provided for all the circuits in the recreational area. And I'm almost done, guys. I want to see if we missed any good stuff. I love technology when it works. We got that, got that, got that, got that, got that, got that multi-wire branch circuit, got the calculation. Here's what happened for your TV. This is just a good example of this will not happen. This will burn definitely in a multi-wire branch circuit. Does that make sense, guys? Two equipments connected to multi-wire branch circuit. Now this equipment is supposed to get, so say this equipment is going to get now 180, and what's the leftover from 240? 60 volt will go across this TV. Now you burned your equipment. And you know the funny thing is, why it's dangerous? Because that fuse doesn't do anything. Sits there. It's not meant to handle it. When you go guys in the bigger systems, they have an under-over voltage protection. They call it under-over voltage protection. If this is to happen in a generator, the overcurrent protection device will trip immediately. The device will trip on under voltage or over voltage. There's a lot of other protection, but in residential and a lot of application, we don't have over under voltage protection. You see a few fire coming out of it. You know how they solved it, Brad, in other parts of the world? They don't use 2 voltages. Like in Europe, they use only 1 voltage. So this will never happen, at least in residential. In residential. So if you're using guys 1 voltage here, this line does not exist. And they use in most of Europe, they use 220, 230, 240, and 250. These are the voltages to ground. 220 or 230 or 240 or 250. Hot to neutral, hot to neutral. This is the line between a hot and a hot and a neutral. The voltage between these two, pick any one of them depending on the voltage system that you have. And for residential, they give you 1 phase and neutral, so you would never be in a situation where you open neutral. Commercial, yes. Because commercial, they still have to give you multi-wire branch circuit to feed buildings. Commercial, yes. But residential, you never see that problem, other than what we have here. So, just FYI, just in case you decided to go somewhere to. Okay, all right. I'm not gonna. I don't feel like doing that one. I know you guys are exhausted too. Anybody wants to do it? We'll do it one-on-one. Rewiring it. Any question? Yes, sir.
Oh, just one-on-one or advising.
Advising after lunch. I have let me close that. Okay.